Hey everybody, today's a big day. This is when we get serious about combining the trig, arithmetic, algebra, identities, all of it. So, got some rules here. And I put the tips from yesterday on here again because these are still true, right? So, really the first thing is not sure what to do, rewrite everything in terms of sine and cosine. It's a good first step. Look for identities. When you see words squared, look for a Pythagorean identity. It's always going to be a great shortcut. All right, so when you see words that are squared, look for the Pythagorean identity. So we really just have one rule. We're trying to make one side match the other. So you're only allowed to work down one side. It's your choice. It's an identity, so both sides will work. But you can only work down one side. So the smart thing to do is to pick the most complicated side. It may feel a little intimidating, but you need to pick the more complicated side. So for example, in problem number 1, if we were to start with 1, what are you going to do with that? You could write sine squared plus cosine squared. You could do some things, but it's almost too many choices. So I'm going to start on the left side. And basically the rule is you're not allowed to go side to side. You can't subtract 2. You can't divide by 5. You can't do anything. You stay on one side only. So I'm just going to draw this little line there just as a reminder. Hey, don't go side to side. So these two things, right here and right here, right, they both have a negative sign in common. So I'm going to factor that out. You don't like theta, you can use x. Because I'm desperately trying to work in that trig identity, desperately. So sine squared plus cosine squared, that is 1. And of course, 2 minus 1 is 1. And so you can see we got both sides to equal each other, and that's how you know you're finished. So yesterday, they did not give us two sides. So yesterday, when we were just simplifying, it's hard to know. When do you stop? So today, you have the answer. Your task is to show the middle, all of the work. And it's really just about you being aggressive, being willing to try and try and try and try and try and try and try, which I know doesn't sound too fun, but that's really kind of how it is. Secant squared minus 1. Are you looking at your Pythagorean identities? I hope so. Because don't think distributive property. That's not what you want to do. Pythagorean identities. Look for them. It's always going to be a great, great shortcut. All right, so secant squared minus 1 is tangent squared. So we're going to have cosine squared x times tangent squared x. And again, I'm not crossing over. So the goal is to get it to look like this. Well, of course, now I'm to a point where it's probably best to put everything in sine and cosine. And so sine or tangent squared is sine squared over cosine squared. Since we're multiplying, the cosine squareds will cancel out and we get sine squared. Well, normally I would say that's a great answer, but look at the answer. Look at the answer. Allow the answer to drive what you're doing. Well, sine squared, right, because we know that sine squared, I'm just going to abbreviate, plus cosine squared equals 1. So if we subtract the cosine squared over, we get 1 minus cosine squared equals sine squared. So sine squared can be written as 1 minus cosine squared. I would say normally that's really a stupid step, but that's what the problem wanted you to do, so that's what you do. Number 3. Addition is always more complicated than multiplying, right? So we want to pick adding. Adding and subtracting is more complicated than multiplying. And dividing, always going to be the most complicated, so even though you may be a little bit nervous about picking the dividing side, you should. So tangent, well, there's no squared, so no Pythagorean identities. Tangent is sine over cosine. And cotangent, oops, it's a plus sign, is cosine over sine. Well, when you add two fractions together, you got to have a common denominator. So the common denominators usually multiply the two together. So this is my common denominator, cosine sine. So I've already got the denominator. It is finished. So in this first fraction, I multiplied the bottom by sine. So I have to turn around and multiply the top by sine. And the second fraction got multiplied by cosine. So you have to multiply the numerator of the second fraction by cosine also. And now you can see we have sine squared plus cosine squared. Oh, Pythagorean identity, that's a 1. And as you know, we generally don't want to have fractions. So if you think about what is the reciprocal of cosine, that's secant. What's the reciprocal of sine? That's cosecant. And when you multiply, the order doesn't matter. So I know I didn't write it exactly in that order, but it does match the other side perfectly, so we're good. Number 4. I'm going to start on the right-hand side because that's a fraction, and I'm going to make it messy. It's going to get real messy. Real messy. All right, so that secant plus 1 is the goal. Sine theta over 1. Tangent is sine theta over cosine theta. And then I have 1 minus cosine theta on the bottom. Doesn't look like I did much, but you got to start somewhere. That's what I mean. You just have to be willing to try something. Be aggressive. I'm going to rewrite this fraction. I'm going to run out of space. I'm going to go here. Sine squared theta over cosine, right? That's my numerator. And right, if I just multiply across the bottom, across the top. And then the denominator is 1 minus cosine theta over 1. So if you don't know me, I like to simplify my complex fractions like this and like this. That's what I would do. Or if you want to think of it as this is sine squared theta over cosine theta divided by 1 minus cosine theta over 1, which means you have to invert and multiply. So we're going to have sine squared. This is already taking up too much space, but I wanted to write it out. Sine squared over cosine times 1 over 1 minus the cosine. Sine squared is 1 minus cosine squared. I'm taking that out because it doesn't really match the bottom. Look where I'm trying to go. I'm trying to get to secant. Secant, right? Secant. I know you can see it. Secant doesn't involve the word sine. So let's try to get rid of the word sine. 1 minus cosine squared. I took out the sine squared and put that in. And the bottom is cosine times 1 minus cosine, because you have to multiply that together. Well, 1 minus cosine squared, this is the difference of two squares. I'm not afraid to use some algebra. So it's 1 minus cosine times 1 plus cosine. And the denominator is cosine over 1 minus cosine, which of course cancels. All right, so this is where it gets a little bit weird. Again, we are using the answer to drive our choices. Your denominator is really the denominator for all of it. If you have 1 plus x over 2, this would be 1/2 plus x over 2, right? Because that's how you got there. When you add, your common denominator stays, and the numerator is where the adding or subtracting is. So this is 1 over cosine plus cosine over cosine. The denominator goes with everything. Well, 1 over cosine, that's secant. And cosine over cosine is 1. And that was the goal. That was messy, and there's lots of shortcuts we could have taken. But just because this is new, I wanted to go through it step by step. Last one. This is a big one. This is why it's the only one back here. All right, you think, oh, just one problem. No, it's going to take up a lot of space. And by that, I mean left to right. All right, so again, we are adding fractions. I'm going to work down this side because, well, subtracting fractions. Let's start with the common denominator. Let's start taking some shortcuts here. Our common denominator is the two denominators multiplied together. And I'll fix that here in a minute. Right, we know we can multiply that together, but that's the common denominator. So essentially, this first fraction has to be multiplied by sine x minus cosine x. And the second fraction has to be multiplied by the sine x plus the cosine x. I'm going to rewrite it, but that's where I got that from. So it starts with the cosine of x, and we're going to multiply that by sine of x minus the cosine of x. Now here's where you really have to pay attention. This is a minus. It's a negative sine x in front of this second quantity, which is the sine of x plus the cosine of x. Now we distribute. Right, so I'm going to distribute all this stuff. I'm going to distribute the negative sign. I'm going to multiply the denominator. I'm doing all the multiplying. So I get cosine x, sine x, minus cosine squared x. Now again, it is negative sign that's being distributed. So this is going to be negative sine squared x minus sine x cosine x. The denominator, I'm always looking at my answer. The denominator looks like we should multiply this together, so I'm going to do that. So this is going to be sine squared x minus cosine squared x, because that's the difference of two squares, and that's what you get when you use FOIL on that. Let's go back to the numerator. Looks like we have a negative sine x and a positive sine x. So what we have left is negative cosine squared x minus sine squared x over this. Now the denominator is good. The denominator is the goal, but the numerator is not. So we don't like it when there's negatives. So, right, the Pythagorean identity is positive. So I'm going to factor out that negative sign because they both have it. And you get cosine squared x plus sine squared x. And the denominator, of course, is the same. And what do you know? Cosine squared plus sine squared is 1. And so we get negative 1 over sine squared x minus cosine squared x. Please write the answer. I know that this is the answer. You know that that's the answer, but I want to know that you think you're finished. So please write the answer. Write it. It's as simple as copying it from up top, but please write the answer. Show that you are finished. So again, just try it. If you get stuck, stop. And don't get frustrated by this. Sometimes it just takes a little bit. Some of them are super easy and quick to do, and some of them just have tricks. We'll work through all the tricks. Just get in there, try something. If it doesn't work, so what? Stop. Don't erase your work. We can fix what you have possibly and just bring it into class, and we'll go through it.